Hello everybody. So welcome to Electronics and Electrotechnics course. Today we're going to learn about Kirchhoff's current law. Last class you learned about Ohm's law, right? Basic law. So today we're going to learn about Kirchhoff's current law. There's also Kirchhoff's voltage law. But today let's discuss about Kirchhoff's current law. Okay. What is Kirchhoff's current law? Definition. Let's write the definition first. The algebraic sum of currents at any node is 0. Okay. Kirchhoff's current law means algebraic sum of currents, alright, sum of currents at any node is 0. Means you have a connection point, we call it node. Node means connection point. So let me draw, then it will be easy to understand. Let's say, make this bigger. Let's say we do have this type of connection. Okay, and this part is a connection, right? These three wires coming and connecting there. It's coming from here, let's say. Current is coming from here and it's splitting at this point, at this node, into two. One is going that way, one is going this way. Okay? We call this connection point is a node. Alright? Okay. Let's say this node is, we can give a name, A node. Right? This connection point, we call it A node. Alright. Next thing is we calculating current now, right? So let's give a current here, I1. And this one, let's say this is I3, and let's say this one is I2. Okay. Current. These all three are currents. Right? So next thing is, if current is coming from this way, that means it's coming into node, right? If it's coming into node, we call it negative node. A negative current, sorry. And if current is going away from a node, this I3 is going away and I2 is going away from node, right? Because current is coming through I1. So when in the node A, they splitting. I1 is splitting into two, I2 and I3. So I2 and I3, we call it, it's going away, it's leaving the node. So we call it positive current. Okay? Let me write down that. If current going into node, it's a negative node. It's negative current. Okay? And if current going away, it's leaving the node, from node, it's a positive current. Okay? So we have here, I1 is coming. Let's say the current is coming through this way, from left to right. So I1 is going into node A, so it's a negative node. It's a negative current. And I2 and I3 is leaving the node, so it's a positive current. So we have a simple formula for that. Let's write formula. Let's move this, and we'll write it. This was definition. Okay, let me write the formula. Formula is, we call this I1 is a negative node, right? Because it's going into node, so it's a negative current. I1 negative plus I2 is positive plus I3 is also positive equal to 0. Okay? Okay, now this definition is, we can call this proving, right? Let's say this. Okay? So algebraic sum of currents at any node is 0. So algebraic sum of currents are these three: I minus I1 minus I2 minus I3 is equal to 0. Means I2 and I3, sum of I2 and I3 is equal to I1. For example, if I1 is equal to 10 amp, right? That means I2, let's say I2 is 2 amp, and I3 automatically should be 8 amp, because sum of I2 and I3 should be equal to I1. So if you say I1 is 10 amp, if you split equally, I2 and I3 becomes 5 amp each, right? It's like let me take this also. Okay, let's put this formula up here, right? You know the water hose, right? If you have water hose here, and water split from this point into 2, let's say it's splitting into 2. Let's say this is smaller. This one is smaller and one is bigger, right? This one oh, sorry about that. Okay, let's make this one come into here. Okay, and this is a connection point, right? Okay, this, let's open. Okay, so let's say we have a water, it's coming through here. This is water, right? This is a connection point. In here, it's splitting into 2. We have to remove this also. This is open. So some of the water will go down here, and some of them will go down this way. But main point is here is, let's say, Can we do it this way? Let's say this connection point we call a node, and some of the water goes through this way and some of them go down. But main point is sum of these two splitting point is equal to water is coming here. Let's say this one is flow 1, right? And this one, let's say flow 2, and this down here going flow 3. Okay, so what we say is flow 1 is the main water hose. Its whole water is coming through flow 1, and at this point at the node it's splitting into 2. So flow 1's water, some of them will go down flow 3 and some of them will go to flow 2. So sum of flow 2 and flow 3 is equal to flow 1. Okay, let me write that. Flow 1 is equal to flow 2 plus flow 3. That's the main takeaway from this class. Okay, alright. So now we're going to see the real example. So let me draw an electric circuit first, then we'll see. Let's say we do have electric circuits. Let's say, okay. Let's say we have this. We're going to put a resistor there. Resistor, this is a resistor, and this is a resistor, and we also have, let's put here also a resistor. Okay, and let's throw here also a resistor. Then we'll give it values, right? Then we have a power source here, power source plus minus, and this one is current, source current, so we call IS. Okay, I of S, and let's put this one I1. Okay, and let's say this current is going down here, right? Going down here, so let's say this one I2, and we have one more current here, I3. Okay, all right. So let's initialize. We have, where is the connection points? Here's one connection point. Here's one connection point, right? We have a two connection point. Let's say this one we can give a name, node A, and let's give this one node B, name of the connection. Let me write this way, B. Okay, and let's give some values to our currents. Let's say I3 is equal to 2 amp, 2 amp. Let's say I2 is equal to 6 amp. Okay, and let's say this resistor has a value of 10 ohms, right? So now question is, what is the current going through node B, right? So we will apply Kcl Kirchhoff Current Law at node B. Okay. All right. So okay. So first we have to write down the formula. So what is the current going through the B? What is the current coming into B? Going into B. So I1 is going into B. Formula, right? I1, so if it's going into B, so it's a negative. Plus I2. So I2 is going away from the node B. So I2 and I3 also going away from the B, node B. So equals to 0. Now we know some of the values, right? Negative I1 plus, what is the current I2? Value of I2 is a 6 amp plus, what is the value of I3? Is 2, right? Is equal to 0. So negative I1 plus 8 amp is equal to 0. Okay, negative I1 equal to negative 8, and let's say I1 is equal to 8. What is the value of current? Is amp, or the unit of current, sorry. So it's 8 amp. So now we know the value of I1. So I1 has value of 8 amp. Okay, so we find out through this simple formula. So next thing is, in the test or in the exam, I might ask you, what is the voltage going through 10 ohm resistor? So this one, voltage. Find the voltage. What is the voltage? So when you heard about the voltage, you have to apply the Ohm's law. So what is the Ohm's law? Formula is very simple, right? V equal to R times R, right? So V equal to, what is the resistor's value here? 10 times, we found out the current. Now, I1 is 8 amp, right? So voltage is equal to 80 volt. So now we know the value of voltage going through the 10 ohm resistor. So it's 80 volt. It's simple, but it looks complicated, but if you do a lot of exercise, you will get better. Of course, in the next class, we're going to learn about Kirchhoff's voltage law. Then after that, we will